Hi, good afternoon, good evening, good morning to whichever part of the world you're joining from. Hope you're all doing excellent. My name is Mudit. I'm one of the founding members of DeFi, and I'm stoked to welcome you to this particular live session with Alexey. Um, I guess we can see a lot of comments on various platforms. Whichever platform you're joining from, be it DeFi, LinkedIn, or YouTube, I would really request if you could drop a comment to let me know that yes, I'm live and you can hear me clearly. That will be sublime in nature. So I'm just waiting for a couple of comments on a few platforms. Yeah. Hi, I can see a lot of comments on LinkedIn, on YouTube. Probably, one second. Let me just check if we are live on LinkedIn as well. Then we'll kick off right away. Just a moment. Yeah, Neil, thanks. I'm just checking if you're live on across on other platforms as well. So, by the way, quick hi to all of those who have commented. Alex is also with me on the background. I'll loop him in quickly once we start off with the session. Just give me a moment. I'm just checking if we are live for everyone who have joined in. Yes, yes. Great. I think we can get started perfectly. Awesome. So thank you for joining in. I think there is some lag in terms of comments, but don't worry. We'll be keeping a note of all the comments, all the questions that we'll be putting across. So yeah, for those who have joined in now, I'm Mudit. I'm from DeFi's team. We are a global community of data science, and this particular session is with our old friend Alexey, who has a ton of credentials. I'll be talking about it very briefly. Let me just share my screen to give a quick context in terms of DeFi briefly for those who are new, and then about the session as well. I believe you can see my screen. So today we'll be talking about machine learning on streaming data, what streaming data is, what do we do here, and how it is executed, use cases, and everything. That is something that Alexey can explain at least 10x better than me. So I wouldn't even be giving a shot at it. Let me just give a quick intro of DeFi. So we're a global community of 100k plus AI enthusiasts, and we're on a mission to teach and build AI for the world. What's interesting is that all resources are 100% free on our platform, including bootcamps, courses, live expert sessions, AI challenges, and more. And often we collaborate with communities who are willing to, who have shared missions and we are firm believers in. And one of them is DataTalks Club, which is founded by none other than Alexey. So we have a particular bootcamp running in collaboration with DataTalks Club. It's created by DataTalks Club itself, and they have been super kind to allow us to share it with our community. So now it is running on our platform. These are some of the things that are being covered: data ingestion, data warehousing, analytics engineering, batch processing, streaming, and then last 3 weeks are around projects, as I recall. Alexi is one of the main instructors for the bootcamp. We have Sejal, Victoria, Ankush. All of them are seasoned ML engineers and data scientists. Apart from that, we have two other boot camps which have started, and they'll be closing for registration this week. It's with IT Bombay's Analytics Club, data science, and second one is around deep learning. So if you want to take it forward, if you're already into data science, want to learn further on those lines, this particular boot camp will be for you. Now, coming on to Alexey, right? So Alexey is a principal data scientist at OLX. He's also the founder of DataTalks Club. Like DeFi, DataTalks Club, is a global community, and it's a platform where he creates some really excellent content that people can consume to learn applied data science skills. They currently have an MLOps Zoom camp running. The data engineering boot camp running on DeFi is created by DataTalks Club. So it's a very thriving community that way. Apart from that, this last line is added by us. He's usually very modest in terms of talking about awesome things that he does, but yes, he's definitely an avid speaker, a change maker, and educator. He often comes forward to educate the community, and we're glad that he's with us today. He'll be taking the stage as I loop him in. So let me just do that. Okay, hi
Hey,
Alexi. How
change
are you?
maker, that's nice. I need to use that.
Yeah, certainly. I mean, that is something which comes very intuitively when I think about someone like you. So thank you so much for joining in. We are super glad to have you on board. And by the way, we have seen a superb response from the community. We have received over 400 registrations from the from emails, and then DeFi plus
Wow.
LinkedIn and other platforms. So I think people have joined in. So we'll just start off. I'll leave the stage to you for you to start off with the topic. I'll be in the background for those who want to ask questions. The Q&A session, I believe, will be towards the end, right? So
Mhm.
we'll be there. We'll be curating all the questions that you want to ask. So feel free to put them across in the comment section. We'll have a look at it.
Yeah. I think what I can do is during the talk today, when there are certain logical blocks, and then after each of these blocks, we can have like 5 minutes for questions. I think that's better than waiting till the very end, because we have a long session today, and then by the end of the session, maybe the questions that people have right now, they will be out of context. So I'll try to remember that when we go through the session today. By the way, how many people are live now?
So we don't see stats for all the platforms, but I guess somewhere upwards of 100, 200,
Wow.
I believe. Yeah.
Hi everyone,
So,
thanks for joining in today. Okay, so I guess I should start. So I'll just share my screen. I hope it works. I don't often use the platform we use currently. Okay, now you probably see me. Let me know if it works. Oh, that's something weird. Okay, and I prepared slides. So today I'll talk about model deployment. And actually, well, the topic is more like streaming. But in general, we'll talk about model deployment as well, and we'll discuss different options for model deployment, and we'll focus on one particular one, which is streaming. So I don't think I need to talk about myself anymore, because yeah, thanks a lot for the intro. That was a very nice intro. Maybe I'll just add a few words about what I do at OLX. So I work as a principal data scientist, and what it means for me specifically is I help people with a lot with engineering aspect of data science, like engineering, architecture. So this is my main focus. So not training models or not tuning parameters, not selecting the best model. This is all important, of course, but more like how do we productionize machine learning models. And this is what I'll talk about today as well. And yeah, if you are interested in finding me on social media platforms like Twitter or LinkedIn, if you manage to decipher my handwriting, then you will be able to find me on these platforms. So I'll continue. So as was mentioned already, we are running a course, a free course also. We also have this mission of giving people free education, educating everyone, making education accessible in the data world. And one of the things we're doing right now, one of the courses we're running right now, the course started on Monday. It's called MLOps Zoom Camp. And today, actually, I will talk about one of the modules of that Zoom Camp. So here, let me just show you. So this is our repo. And one of the things here, one of the modules is model deployment. And we partly cover that module, not the entire module, of course. I still want you to hook you to this content and register for the course. Please do this. But I partly will cover this content from the module and focus. First, we'll talk a bit about different ways of deploying models. And then we take a look at this one, streaming, like how do we go about deploying models in the in streaming settings. Okay, so please give us a star. So this is the link. Your stars will help to spread the word about the course. And let us start. So actually, I prepared this document to help me remember what I need to cover. And the first thing I have here, let me just make it larger so you can see it as well. So the first thing I have here is ways of deployment, online, offline, and so on. But maybe before that, I'll briefly talk about general process of machine learning process. So a very high-level overview, like helicopter view of the process. In this view, we can think of a machine learning process as it consists of 3 stages. So the first stage, I would call it design. I don't know if it's design, if I spelled it correctly. But anyways, this is like the first stage of the process. At this stage, we collect requirements. We understand what is the problem we're trying to solve. And one of the important things here is deciding understanding if machine learning is the right solution for our problem. And through doing this, like after some time, we realize, okay, yes, machine learning is indeed the solution that we need to use for solving this problem. We come to the second stage of the process, which I'll call train. This is actually where we try different models, see what model is the best one, try different features, try different ways of approaching the problem. So this is where the actual quote-unquote data science happens. Right? So that is like the second stage. And usually the result of this stage is a model. So it can be something that data scientists create at the end of their Jupyter notebook or something similar. So we have a model. And then the third stage is operate. So we take this model and we deploy this to production. This model goes live. It affects the users. Users benefit from this. And then, yeah, so this is actually what we call model deployment. And of course, the story does not end there. So after we deploy a model, there is model monitoring, like how we can make sure that the model behaves well. But in this particular session today, we will focus on deployment. So we will, let's say, talk about a part of this this stage, which covers deployment, right? And when we talk about deployment, there are multiple ways of doing this. So deployment, and the first thing we need to ask ourselves when we deploy a model is how soon we need predictions. Can it wait? Like if it can wait, if we don't need to run this model all the time, if we can just run it regularly, then we can go with batch mode. Batch. So this is like run regularly. So it's not up and running all the time, but yeah, only once per day or once per hour or something like this. Then if we need our model up and running all the time, if we need to have the response, the prediction as soon as possible, then we go in, I would say, I'll call it online. And for batch, I would say this is offline. And for online, we can have again two options. One option is a web service. So if you know tools like Flask, for example, so this is just a web application, and then our model is deployed as a web application. And then the third option is streaming. This is similar. Model is up and running all the time. It just, instead of getting requests, HTTP request, it gets messages, it gets events. And now I will talk more about each of these things, and I'll start with batch. Okay, I'll just quickly check my notes to make sure I don't forget anything. Yeah, so when it comes to batch, this is something we run regularly. So we don't need predictions of our model right away. We don't need this immediately. It's okay to wait a little bit. And good examples for batch usually come from marketing. So in marketing, for example, churn prediction, right? Imagine that, like, let me talk a bit about OLX. So this is, no, maybe not OLX. I just want to give you a good example. So maybe I'll talk a bit about OLX later. But let's say this is the example we use in the course. So in the course, we use the New York City taxi data. So in this data, we have in this data set, we have information about all taxi rides that happen in New York City. And imagine that you are a user, so you want to hire a taxi. So you have your app, and then you have like a car here that you want to hire a taxi. And then what you do is you open your app, and then you order a taxi. You say, I want to go from this location where you are now, you want to go to this location, right? And then you use your app for that, and then the taxi comes, and yeah, you just go, like, I don't know, here. And what we want to look at, like, this is the settings, and one of the models that is interesting for us could be predicting the duration of this ride. This ride duration prediction is maybe it's not the best problem actually for batch, but in these settings. So let's say we are a company who who owns this app, like, I don't know, that doesn't matter. Like, we are a company that has the app, right? And some of these people here, they might decide to go to a different app, right? Maybe they decide to use Uber, right, for hiring cars. So, and this is called churn. So these people churn, they stop using our services, and they start using services of other company. Right? And a good example where we can use batch models, deploy our models through batch, is churn prediction. Right? So if somebody is about to churn, to stop using our services, and let's say go to competition, we don't need to know about this immediately, right after they made the decision to churn. We can just run our script, our model every day, and then at the end of the script see, okay, maybe this user is thinking about going to Uber, switching to Uber. Maybe we will send them a push with some promotion saying, okay, for your next trip, here's $10, right? And then this would be, because our model said you're going to churn, we will send you a push, this way preventing you from going to competitors. So this is something we can deploy in batch mode. Then, for example, another thing could be lead scoring, also from marketing. Let's say you are a company and you have a lot of potential customers. So people who have not became your customers yet, but they, let's say, filled in a form on your website. So they are thinking of becoming a customer and they want to see a demo of your tool. And you want to help your sales team to prioritize these potential customers, prospects. And then you can have a model that looks at all the prospects and says that this prospect, this client, this prospective client, is more likely to convert and start using the services. This is something you can run, let's say, every day or every week. You don't need like a model up and running all the time. Yeah, there could be many more examples, but let's move on. And then I'll talk a bit about the other thing is web service. This is when we need to have the predictions right away. And the example we had here with taxi duration prediction. So again, you want to hire a taxi. So you use an app, and then you talk to a web service. And this web service, let's say, has our model. So this little thing here is our model that, given your location and location where you want to go, and the time of day, and I don't know, distance, whatever, it can say that you send a request. It can be JSON, and then it replies with the response saying that this trip will take, I don't know, 30 minutes. So you deploy this kind of model as a web service. And yeah, typically what you use here is things like, I don't know, Flask, or like Fast API for wrapping your model into a Python application, into a web service, and then you deploy it to, I don't know, for example, Kubernetes, or any other container management system, or any other place where it's possible to deploy a web service. And for example, here for batch, I think that the usual tools you use here are Spark, or Kubernetes jobs, or AWS batch. Yeah. So here, web service, this thing that we have here, it's up and running all the time, right? So it always has to be up and running. Because the moment, so here we are making a decision whether we want to hire a taxi. We need to know how long it will take before we press the hire button, or I don't know. I don't remember how this button is, what's the name of this button, but before we press the button, before we order a taxi, we want to know how much it will take and how much it costs, right? So for these things, we actually need to have the prediction of the web service right away, right? So we cannot wait for 1 day before we know this. And so this is a good example of a service that we would like to deploy with as a web service. And then when it comes to streaming, the architecture is a little bit different. So here, web service is it's client server. So the client sends a request to the server, and then the server replies back with the predictions, right? And the client needs to wait while service processes the request and then sends the prediction back. So this is sort of like one-to-one relationship, right? So there is, while the request is happening, there is always this connection between client and the server. In streaming, it's different. So in streaming, let's say, if we talk again about the same settings as previously, so in streaming, let's say you use this app to order a taxi. So this can be, again, have a web service that tells you, okay, the ride will take 30 minutes, right? You decide to order to hire a taxi, and then the event that trip begins, we send this event to a messaging system. So there is a new event, and this thing is like a message broker, and we send an event to this message broker saying that this user with this ID is going from this location to this location, and yeah, the event is the trip has begun. And then some things can listen to these events. So previously we sent a request to only one service, right? But here actually multiple things can listen to these events. So there, for example, can be a service that calculates whether you will leave a tip or not, for example. And if the model thinks you will leave a tip, maybe it can send, I don't know, a push message to your phone saying, hey, how about leaving a tip, or something like this. I don't know, I just made it up. Then another thing that can happen here could be another service that, for example, here we have a model that makes prediction of the duration, but maybe we have a more accurate model that just takes a little bit more time to predict. So maybe this is like another duration prediction model that is more accurate, and this model can just pull the message that the trip begin, and it can use more information to later update the duration and say, okay, actually, we looked at this and we think that instead of 30 minutes, it will take 20 minutes. Right. And yeah, could be like here, we can have as many services here as possible. And this thing is called, like, this is producer. And these things are consumers. So here the relationship is different. So here we have client server. So there is always this connection between the client and the server while the request is happening. But here this producer just sends an event, and it kind of doesn't care what exactly happens with this. So like, as far as producer is concerned, it has sent an event and it doesn't care with what happens after that. And then there are a ton of consumers. So here it's more like one-to-many relationship rather than one-to-one. And this way of deploying models is quite useful when you don't need to make a decision right away. So it's not blocking you. So for example, here, it's kind of you're blocked. You cannot make a decision whether you want to hire a taxi or not until you know how long it will take, right? But sometimes you can design your system in such a way that it's okay to send a message and then wait till some of the components reacts. And then I want to talk about another thing, like let's say YouTube. So on YouTube, you can upload a video, right? So you upload a video on YouTube. So this is supposed to be a play button. You upload a video on YouTube, and then what happens is that there is a message that video is uploaded. And then multiple things can pull from this message broker. For example, one of the things that pulls a message from here can be copyright violation model, like copyright violation model. Right? So they look if this new video violates a copyright, and then if it thinks that it violates, maybe it can post a message, okay, I think this video is suspicious, and then maybe there is a service that, I don't know, decision service that says, okay, we need to pull this off, like remove from the platform. So the user kind of published it, and then eventually some checks will happen. And because of this, because of like we use the stream, some checks will happen eventually. And if this actually violates any copyright, the video will be removed, but not immediately, because we do not want to block the user from posting the video immediately when they do this. Another thing can be like, for example, not safe for work detection. Here, maybe there is some pornography or explicit nudity or something like this, or maybe, I don't know, violence. So all these things can be separate services that consume from this event stream and make some decisions. So they then they put the decisions to some other event stream, and then there is some decision service that decides. So this is quite a classical application of streaming, and I would call it content moderation. Content moderation. And for example, at OLX, we also have a content moderation system. So at OLX, you can create a listing. Like let's say you're selling an iPhone, then you go to OLX and then you create a listing, iPhone of this price, for example, and then the similar thing is happening. So our content moderation platform is implemented quite similar to this. So we also have like a streaming settings there. Another example where we use streaming is our recommender system for jobs, I think. So yeah, in general for recommender systems. Let me create a few more pages here. So, for example, let's say you as a user, you create a new listing, I don't know, iPhone. And then the event about this is sent to the message broker, to the event stream. And then what can happen is there could be a recommender that can see, okay, there is a new phone, let's check a database. So this is, let me draw it better. So there is some database with other listings, and then we can look this up in the database and see, okay, what are the listings that are similar to this new listing, new iPhone. And then we can publish another message saying that for this listing, these are the most similar listings. And then this can go to our recommender, to the page where, like, there is a listing, there is some information about the phone, and then there is a customer who saw this item also looked at these items, right? And then we can have a recommender block. Actually, what I described is something we do for jobs, but in principle, for recommender systems, this is a pretty common approach. We use a slightly different approach for recommender systems. It's more like a batch mode with very small intervals. But yeah, in principle, this recommender system flow is a very nice candidate for streaming. And I think it's enough with theory. Maybe I just quickly tell you possible possible technologies and frameworks that you can use. So usually for these message brokers, you use things like Kafka or Kinesis. And these blocks, like these consumers and producers, they can be implemented in, like you can deploy them anywhere. So for example, common places where you deploy them is Kubernetes or AWS Lambda. I think I didn't get it right. But actually what we will do today is we will see how we can do this with Kinesis and Lambda. And for now, I think I'll stop. And I've been talking for quite long. I hope we'll have enough time to do the practical one, but enough with theory. And I want to quickly check if there are any questions. So maybe I'll just quickly take a pause.
Yeah, hi. So there are a few questions. So first of all, okay, related to the topic, right? There is this particular question that me has asked is, I mean, I'm not. This is slightly contextual, but I suggest you to take this up. Is it the same with propensity modeling? Sure. If
I don't know actually what is propensity. What is propensity, do you know?
me, no, I think me can comment. Yeah.
I think propensity sounds familiar. Yeah, I don't know. Are there other questions?
There is one question which is I'm not sure if you'd want to take it now. So Chris is one of our most active community members. He has asked this particular question, which is more on the career side.
Yeah, let's keep
Want to
it
take
at the end. Yeah.
Okay. Awesome.
I'm
So
happy to
apart
answer
from
that, but that can take a while, and I want to make sure that we finish the practical part, because
yeah,
like enough with theory, it's like prediction modeling. Sorry, I don't know what it means. Like prediction modeling is pretty much machine learning in essence.
okay,
Yeah.
probably we'll proceed in that case, I guess. Yeah,
Okay. Yeah.
but
Apologies. I just don't know what this term means.
yeah, I
Okay.
think yeah, sure. You can.
I will just share my screen again. Okay. I have shared my screen. And now I am in AWS console. So as I said, I think I told you that we want to see how to do this with Kinesis and Lambda. And for that, I will first talk a little bit about Lambda. Actually, let me look at the plan. Yes, Lambda. So let's start with Lambda. So for Lambda, and actually there is a good link that I will follow to some extent. So this is a link I found in Google that describes like how to set up Kinesis and Lambda together. It's a tutorial from AWS. And some of this material is based on that. Yeah, so it talks about prerequisites. So I already have, so I have a terminal here. Yes, so in this terminal, I have AWS CLI installed. So if you do not have it, you need to do pip install AWS CLI like that. And then you also need, of course, to have a AWS account and configure your AWS CLI. You can look it up how to do this. I already have done this. And then the first thing the tutorial says to do is to create the execution role. So this is something, so let's say we have Lambda. So Lambda is, Lambda would be a thing that consumes from the stream. So we have our event stream, right? And then this is our Lambda. So this Lambda needs to be able to pull, to connect to the event stream, right? So we need to give it permissions to do that. And this is what this first step is about. So it says that we need to create a role, and role, this is something that will tell AWS how much, what exactly can this Lambda do. So let me go there and do this. It's done in IAM section here. And I'm wondering why I am in US East. I think it doesn't matter. So go to roles. So I'm doing everything in Ireland, but for you, you can just select the thing that is closest to your geographical location. So go to roles and I create a new role. And I'll use the name they suggest. So they suggest Lambda Kinesis role. So I'll use that role. So let me make it larger. So here, when I create a role, I'll just select Lambda here. Next. And yeah, I was too early to copy the name. What we need is these permissions. So now I'll just put it here, hit enter, and we will find this. This is a predefined role from AWS that we can use. So this role allows to get records from Kinesis. So you see it has only read permissions, so we can get records. And we can also create some logs. Right? So this Lambda will be able to get messages from the event stream, and it will also save logs to a special log place, right? So this is what it will be able to do. We don't need anything else right now, so I just click next. And now we give this thing the name, which is Lambda Kinesis role. I think that's enough. Yeah, trusted entity. So it means that this role can be taken by Lambda, but this happens automatically. This happens automatically. We don't need to worry about this because at the beginning we selected that we create this role for Lambda. That's why it added this thing. So create role. Okay, did it actually create? Okay, it did create. And now I go to Lambda functions. So here I just type Lambda. I have a typo, Lambda. And then I have Lambda. I already opened it here. I have two Lambdas here, but I will create a new one. And for now, I'll just select this one, author from scratch. And this Lambda can be test Kinesis integration. In the tutorial, they use JavaScript. We will not use JavaScript. We will use Python. So they have Python 3.9, which is good. And here we need to select the execution role. So we select the existing one, which will be this Lambda Kinesis that we just created. We'll create a function. I think I can close this one. Yeah, so Lambda is being created. And we can quickly test it now. So let's say here we will just, so this event, this is the thing that will come from here. So right now we don't know how exactly it looks like, so I'll just print it to see how it looks like. And yeah, I will remove this one. This is something that the Lambda will return. And now that there are changes, I need to deploy these changes. And now I can see, I can test this Lambda function. Okay, I'll create a new event. I'll call it test. And this is something that AWS prepared for us. I'll just go with this event. Okay, test. And we see that, yeah, this is the response we got. This is this response. All right, and then we also see that Lambda printed the request. So this is the event. So we just print it, and this is what we sent as the event. Okay, so far so good. Now let's connect it to Kinesis. So for that, we just add trigger here, and we select Kinesis here. And yeah, of course, I haven't created a Kinesis stream yet. So let me do that. And Kinesis is this. This is the message broker we talked about. So this is a thing that we can put events to, and then we can consume these events. So I'm in Ireland. This is also Ireland. It has to be in the same region. So I create a data stream. This one, Kinesis data stream. and then the stream name. And by the way, this is actually, you see, this costs some money. You see pricing. It costs like almost 2 cents per hour. So be careful, like when you create, make sure you remove it after you experimented with this. So you don't, if you're just studying this for experiments, you don't want to keep it running all the time. So don't forget to turn it off. So data stream name, I'll call it write events. This is something that here don't have this example. I think, yeah, here I talked a bit about this. So the settings we have here is, first of all, there is a model that is deployed with a web service that is not very good, that just gives a more or less okay estimate, but then we refine this model with a more accurate estimate. And yeah, so we have this stream here, and this stream we can call write events, right? And then this will be our Lambda, and this will be our Kinesis. So I'll call it just write events. I'll have it provisioned, one shard. Well, we actually, like in practice, we need to see how many shards we need. It says that what is the total capacity. It's for us, it's a toy problem, so we'll just go with one shard. And I'll click create data stream. Okay, so it's being created. It says it can take up to 10 minutes. I hope it will be less, because we don't want to wait for 10 minutes. Okay, now let me quickly just update this. So even though it says it's created, it might not work immediately. So I'll hope it will work. But for live demos, it's always Kinesis write events, and then we left the rest as, like, this is how many events at once it can take. So for example, here there could be multiple events in this Kinesis stream, let's say 10 events or 100 events. So we'll pull 100 and apply the model to each of them, to all the 100, which is a good thing. You, depending on how large the event you have, how large is the information about this event, you can make it smaller or bigger, but I'll go with 100. And okay, this is strange. So let me just try it one more time. So test Kinesis integration. Maybe we didn't use the right permission. So I'll just try one more time and see what happens. Okay. Still the problem. Ensure that, yeah, something is wrong with the permissions. Let me check, maybe something, yeah, we didn't save something, I don't know. Okay, so here I think we need to go to configuration. Like, that wasn't supposed to happen, to be honest. I think it's here, edit, and then it's Lambda Kinesis role, so I need to check it. Okay, so what kind of permissions? Yeah, for some reasons we didn't connect the policy. That one, Lambda. Touch policy. Maybe I didn't add something, I didn't press something, I don't know. Yeah, so now we attach the policy. Is it saved? Yeah, I hope it is. So let me try one more time. So that trigger Kinesis. Oh, great. So now the integration is creating, so it will take some time. But now we can move on with the tutorial. And here, like, okay, we're not interested in this. We created the Kinesis stream. We created the event source mapping. We did all that through the web interface. You can just follow this if you want to do it through command line interface. But now we can test the setup. Right? So this is the command we can execute. Let me open my Visual Studio Code. I thought I opened it before the streaming started. Okay. I just take some time. Okay. Let me show my screen again. Okay. Anyways, while it is connecting, I think I'll just go with this. I wanted to a little bit experiment and put a different data payload here. Okay, let me send it. Yeah, of course, I need to change the name. So stream name was it's right events, right? Events. Okay, now we put something to the stream, and our Lambda should react to this. Of course, this is not our request. This is not what we want to score. But let's see, like right now, I think our Lambda should work, should have executed. Let's see. I think I need to go to logs here. Okay, I just click here, view logs. Okay, I don't know why everything takes forever to open. And this is actually, yeah, this is what we have here. So this is what we printed, right? And maybe it's actually better if what I do instead of that is I print this in JSON, so later we can use it, we can just copy paste and put this to test. So I'll do JSON dump s, and then it will turn this event into a JSON string. So now I will deploy, and then I will send another test. This is a test 2. And now the new version of our Lambda should process this. So I again go to logs. Because we deployed a new version, we have a new log stream. This is the new one. And this is the thing we process now. So this is how event looks like. So you see, it's quite a complex event. So I'll open it in Visual Studio Code right now. Yeah, we see that here, like first of all, there is this object called records, and it's a list of objects. So each of these objects is an event that we pulled from here. It can be up to 100, as we discussed. And then here, this is where our data is. And you see, this is the thing we sent, and it looks kind of funny, right? This is definitely not what we sent here. So it's not hello, this is state test, because it looks very different, right? So the reason for that is it uses base 64 encoding. So here in the article, they say that, oh, do they say that? Yeah, I think oops. Here, yeah, they do decoding using base 64. I have some code for decoding as well for Python. So let me just take it. So where it is? Oh, this one. To our Kinesis. Yeah, here you see that it's actually records. So this is like the first, the main object in this event. So I need to get it records, and it's and inside records we have a bunch of records. So we do a for loop for record in records. And then in these records, we need to go to Kinesis and then data. So I'll go data base 64. The record Kinesis data. And then we need to buy this thing called data row. Now probably I'll just print this data row. So I'll deploy this. I'll click test. Yeah, test. Yeah, of course, because when I do test, like this is the event I sent. And instead of that, I should be sending this one. So let me create a new test event. So instead of sending it through Kinesis, I can test it from this web interface. Yeah, save. And test one more time. Yeah, of course, I need to import. Cool. Okay, it seems to work, and this is the thing we sent last time. So we were able to successfully unpack it. Of course, this is not what we want to send through our model, to our model. To our model, I prepared like a JSON, how it will look like. So this will contain only 3 things. So it will contain pickup location, drop-off location, and trip distance. I actually wanted to show you how to build this model, but I see that we don't have a lot of time left. So instead, I will just go to our repo, and I will show you where you can see the code for building this model. So this is this one, duration prediction. And here, you can see how we actually built this model, right? And the features we use here are pickup location and drop-off location. So this is what we need. And the other feature we use is where it is, trip distance, right? So these are the 3 features our model uses. And that's why we need these three features when we send our request. So I also need to know the name. So the name is right events. So take this and change the statement here. And now I will send this event. So now I will send this event to our Kinesis stream, and Lambda should work and react to this. So these are the features, and this is ID of our write. We could have also added like event type write started or something like this, but I will not overcomplicate it. Now let's go to our Lambda. And we can go, I think I need to actually go to logs here. And then go here. And this is, yeah, so you see that this is the JSON thing that we received. So let me copy this. So we'll use this as the testing event. So I will again configure test event. Why cannot I save it? I'll just create a new one, I guess. Test. And then let me execute this. Yeah, it was quite fast. Actually, this is not correct one. So why it is saying this is test number 2? This is not right. Yeah, I think I needed to copy this one, of course. And test. Okay, now it is correct. And now we want to turn this into JSON. So, or sorry, not turn, but like turn it into a dictionary. So I'll call it data, and then JSON lot s data row as data. So this is something that we will receive and process. So here our model will do the scoring. So for example, features, it's data, how do we call it? You'll see it here. So it's right. Right. And then we have right ID, data right ID. So we can print it here. Right. And here we can do some model predict, and we will return the predictions. So for now, I'll just do prediction, let's say 6 minutes. And here we will send this to another Kinesis stream. Send the predictions. Let's test that it works. So deploy changes. Test. Okay, it seems to work. So this is our features, and this is our right ID. Yeah, so now let's see how we can actually do this, how we can send predictions to another Kinesis stream. So because this is what we want to implement, maybe I didn't show you this here. Let me edit this a little bit. So then we will send the event to another stream. So this will be predictions. And maybe there is some other consumer that pulls from this stream and then updates the actual duration, like I don't know, from 30 minutes to 20, like sends a push or something like this. Yeah, so we need to publish to another Kinesis stream. Let me quickly go and create. Let's create data stream. And I'll call it right predictions. Yeah, create data stream. And while it's creating, I want to implement some code here for putting this to the stream. Yeah, I already created this. I should have it somewhere here, because if I don't, then I will have troubles remembering how to do this. Okay. It seems it's not saved. I don't know why. But I guess I'll just need to Google it. So I'll use Bota3. This put record. This is what we need. So I'll copy this thing. So Bota3 is a library for communicating with Amazon services. So call it Kinesis. And here we is right ID, right ID, and then duration is the spread. This is something we want to send to another Kinesis stream. So we'll do port this one. So just copy this. Now I need to check what are the arguments here. Stream name, data, partition key. This one it. So stream name for us is write prediction. Data for us will be JSON dump as prediction. So it will be the prediction thing from here that we turn to JSON. And then partition key, this is something that internal to Kinesis, because this stream consists of multiple partitions, or they're called shards. So it needs to know to which shard to put. And this is usually done based on the ID. So we will do it based on the right ID. We need to turn it to the string because it's a... Okay, and that's one thing. And perhaps for testing, we want to see these results here. So I will add also all predictions. I'll add here. And I will just add prediction. Okay, good. So now I will deploy it and I will test it. And probably what will happen now is we will have an error. Okay. Which line is it? Okay, let's see. There is another error, and this error, access denied, was calling on put record operation. So the thing is, so we created a new stream. So we created this stream, but our Lambda function can only read from this stream or from other streams. It does not have permissions to write to a stream. So we need to change that. So I will go to this IAM and I will add permissions, attach policy, and we need to create a new policy. I will create a new policy, and this policy will allow us to write to a new stream. So service is Kinesis. This action. So for action, I think we need these put records. That's the main ones. And the read permissions, I think it has read permissions. Yeah, I think let's start with just these two permissions, and we can extend if we need. So usually it's a good practice to keep permissions to the minimum. Okay, what else do I need here? I need to specify the resource name. So add ARN, and ARN is like identifier of this stream. So write predictions. And this is the ARN. Oops, here. What happened? This is the... Okay, so this will have write permissions to this specific stream. So I will not add any tags right now. And write to, I don't know, write string. The name. Okay, now we need to actually refresh it. and permission. Okay, it was attached. Now let's check if it helped. I hope it did. So I will test one more time. And now it was successful. So actually this is the response we have. So it predicted duration 6 because we hard-coded this value, and then it sent something to this stream. And now we can check from this stream. So I have some code for that as well, for checking this. Yeah, it's a little bit complicated, but let me copy this, and here we need to specify the stream name, then shard ID. So there are multiple shards. In our case, we just created one shard, one partition from this, because you read only from one partition at a time when you do this manually. So Lambda takes care of all that. We don't need to worry about this. But if we want to read manually, we need to specify all these things. So let me just execute this code. So this is a way of reading from Kinesis without Lambda, right? And now we can see the records in this results table. So this is where we can see our prediction here, and it's again encoded in base 64, which is very annoying, and we need to decode it. And this thing actually does that. See, this thing records 0 data, so it accesses this one and goes to data and does base 64 decoding. And this is the thing we sent. So this is what we wanted to do. Okay, I see 20 minutes. We have 20 minutes left. I hope that is enough time to actually now turn this thing into a proper model. Let's do that now. So for that, I actually have some code. Maybe we can take a shortcut and do that with a shortcut. So I will open a folder now. Because I already did this, like I prepared these things. So maybe instead of going, what's going on? Instead of following along the code, I am afraid we will not have time to actually do this. I will maybe just show you some of the code I already prepared. Because what we need now is we need to put our scikit-learn model that from this thing here. So here we train a model, and at the end we save this model. So this is where we save the model. So now I want to load this model and put this to a Lambda function, and then react with this model, deploy, use this model to score all the events coming from the stream. Okay, yes, I do trust the authors. So we have this linear regression. And yeah, actually, so this Lambda function, so I will remove all that. Because what I want to do with this Lambda function is I want to take this thing and put it here. So this is our Lambda function, the code we'll have for the Lambda function. And yeah, here, what we need to do is we need to load the model. We do it with pickle. So we have two things there in the model. We have dictionary vectorizer and linear regression. So dictionary vectorizer is needed to turn our categorical features into a matrix. So we need this. And then linear regression is actually the model, right? So let's load this. So I think we need to read it in binary format. We do pickle load. Okay, And here, like we have our features. I'll just have a method I'll call predict, which will take features, apply the model, and return predictions. Just do features. Now we just need to implement this function, right? Here in this function, the features we get, they look like that. So we have pick application and drop-off location, right? But in our model, we need to do a little bit of feature preparation because we combine pick application and drop-off location in one variable. So this way, we look at interactions between pickup and drop-off. So we need to do a bit of preparation here. So I'll do it this way. So features, it's, let me just, I'll copy it from here. Application ID and then drop off this. And then we have a combination, which would be up, drop off. And now our actual features, I'll call them, I don't know, maybe this one I'll call right. And then I'll have features, which are, in our case, where's this feature called PUDO, which will be this combination. And then we have trip distance, which will be coming from here. Also trip distance. We don't apply any transformation to this feature, so we can keep it like that. Of course, ideally, we should use a scikit-learn pipeline for doing these transformations. Yeah, here this is a pretty simple notebook, so we don't do this. If we used scikit-learn pipelines, then all we need to do would be just model.predict, and that's it. But here it's a little bit more complex, so we need to apply our dictionary vectorizer to these features. This will be our feature matrix. And then we need to do in regression predict on this feature matrix, and we need the first prediction. This will be our prediction, and then we just return it. And we need to turn it into float, because otherwise it's a numpy float, which will be hard to serialize. Not hard, impossible. When we do this JSON dump, it will say, I don't know how to serialize numpy float. That's why we need to turn it into this. So let's test it. I already have a piece of code for testing this locally. So I will not spend time on implementing this from scratch. So we will save a bit of time. So what this thing is doing is it takes these features, this request that we have. It does base64 decoding and then puts it here. And then otherwise it's the same request as Lambda gets. And then we just invoke Lambda function from here. And okay, I'll use a different terminal here. Oops. So let me go to this location here. So we have this Lambda function. And actually for dependency management, this is something I also didn't talk about. I use ppenv. So this ppenv specifies all the dependencies that our project has. So if you want to learn more about ppenv, you can check a different Zoom camp we had. This one, we had machine learning Zoom camp. And there we talk about a lot about web-based deployment. And here we talk about ppenv. So check it out if you don't know the tool. Now I will just move faster. I will not spend time explaining the tool. And we need to use this virtual environment that this tool provides. I'll just do ppenv shell. Okay, now I am in the virtual environment, and then I'll do test local to see that things work. Yeah, I have a typo. Transform. And also I just realized that it will send something to Kinesis. Oh, maybe it's a good thing to test here. Test this here as well. Okay, yeah. Because this computer where I run it has admin privileges, so it can actually push to Kinesis. But yeah, it's fine. So I will not now check if we published something. I trust that we did. Now I want to package this in a Docker container. So this function that we just wrote with scikit-learn with our model, I want to put it in a Docker container. So in Docker container, we take our pip file, like all the libraries that we need. So the libraries we need are scikit-learn mostly, and this Boto3 is a library for communicating with Amazon AWS. Yeah, so we mostly care about this scikit-learn here. So this Docker file will install all the dependencies, then it will copy the Lambda function, it will copy the model, and it will tell Lambda that the code for invoking the Lambda lives in Lambda function, Lambda handler function. Okay, so let's quickly build this. I will just do this one. So this thing builds the container. That was pretty fast because I already have this thing here, and I already installed, like run this previously. So that was fast. So the only thing that changed here for me was Lambda function. And I will skip this local testing. What I will do now is I want to deploy this Docker container to Amazon and put this to Lambda. First, I need to create a registry, the thing where I put images, Docker images. So I created, it's called duration model. And now I need this. So this is the thing I will use now for pushing the Docker image I just built. And I will just think. So, and while it's pushing the image, I will tell you what it's doing. Okay, we need to, like Docker needs to know how to actually push to this registry, how to push images. And for that, I use this line. So this line of code authenticates me in this registry. So I run this, and then now I push this image. So what is happening here is like I take the image that we built locally, and then I say, okay, this image, I want to push this image to this location. So this is the registry we just created. It's duration model. And then the remote tag in this image will be v1. This is the first version of our model. And then I just push it. So I take the image we have locally and push it to ECR. Okay, it finished. So now I will take, where is this image? So I need the name of this image. Now we will need to go to Lambda again. So function. I'm wondering if I can just change this thing here. If I can replace it with a Docker container. Yeah, I think the easiest way would be just to delete it. So I will delete it, and I will create a new one from a Docker image. So container image, then function name would be write duration prediction, and then container image will be the thing we just created. Permissions will be this one. Let's create it. Because this time we use scikit-learn, we need to give this function a little bit more memory. So I go to configuration. I think it's general configuration. So I'll just give it 156 and a little bit more time to load. And we will also need to add the trigger to Kinesis, like we did last time. Kinesis, so write events, and I will not change anything here. Okay, so it will take some time now to, like, maybe a couple of seconds. It's enabled. Okay, let's test it. I'm not sure if it will work immediately, but I want to test it. So I will take this code we have for putting things, and I will replace the write ID to something else, 256, for example. Let's do this. Okay, we send something to the stream. Now I go to Lambda, go to monitor, and I need to see the logs, view logs in CloudWatch. Okay, this is strange. Maybe it didn't work yet because this integration, like this thing, this connection, does not work immediately. Maybe it just didn't turn off yet. So let's try one more time to see if something is there. No, but I can just send one more event. And I think that's actually the end of my presentation. So hopefully it should work. But I think while we're waiting for this to happen, we only have 5 minutes left. So maybe it's time I can start answering questions.
Yeah, hi Alexey. Thanks for this wonderful presentation. There are a bunch of questions. We'll start picking them one by one. So I'll just so there's this question that Lucas has asked.
Just sorry, I'll just stop you for a moment. I just want to show you that you see it actually worked. So I will
Yeah,
not
sure,
now
sure,
go
sure, sure.
to. So let me stop sharing this, and now I want to see you. Yeah, please go ahead.
Okay, awesome. Yeah, so there is this question that Lucas has asked. We'll pick them first. So when you deploy models, are the services evaluating the models typically stateless?
Yeah,
And
it
there's a
should be.
follow-on question as well on these lines. Yeah, if not, what approaches do you use that any stateful transformations you did during model training are correctly replicated in the real-time deployment?
I mean, ideally, yes, it should be stateless. I'm just thinking of situations where it can be stateful. Usually we use some sort of database to store the state, right? And then we would go to the database and fetch the state from there. Typically, maybe you heard the buzzword feature store. So this is what you would use like for this kind of things. I must admit that like we don't have like a proper feature store. I haven't used a proper feature store. Usually we just have a database like DynamoDB or something else similar that we use homegrown, where we just request this database, get the state, put this to the model, and use this. But then the rest is pretty much similar to what I show here. Like it can be a Lambda function, it can be something else. It just as an extra step, it goes to database to fetch the features.
Okay. The next question that we have created is this one. So Siab is asking, how would Lambda be transformed for handling a collection of events rather than looking at one individual event at a time?
Okay, so here I'm not sharing my screen, right? Maybe let me just explain it. So here we indeed looked at one individual event at a time, but we have this loop, right? We have the loop over records. So then instead of applying the model immediately to this record, you would first collect all the records, like after doing the feature transformation. So you would put them in one list, and then you apply dictionary vectorizer to the entire list. And then you do model predict to the entire feature matrix, and then you have a bunch of predictions. But now you will need to correlate each of the predictions here with the right ID that you had, and then output everything like one by one, or like there is a put records method in Kinesis in Boto that you can just use for that. So this is how I would approach this. I hope it makes sense.
Yeah. Thanks for answering this. We'll pick the next question. It's a very, very quick and short one. Can you share the Jupyter notebook? So
Yeah. So go to MLOps. So maybe can you share the link?
yeah, we'll share it across. Yeah, we will email it to all the participants. So that we'll also share the link for the MLOps Zoom camp, so they can register for it.
Yeah, so this is the first module, and the notebook there is duration prediction. And there is actually a video where it's like 40 or 50 minutes long video where you can see how exactly I train this model.
Okay, I'll post it on the chat towards the end. In the interest of time, I'll pick the next question that Jazir has asked: how to decide whether to use Kinesis data streams or data firehouse?
So my understanding of Firehose is this is a thing that you, let's say you have a stream, Kinesis stream, and then you want to do something quickly with this stream. Instead of implementing your own Lambda function, you just say, okay, everything that this stream has, I want to dump to S3, right? And then you use Firehose for that. That's my understanding of Firehose.
Okay.
But yeah, typically, like I must admit that this is something I just know how to put a record to Kinesis, and then I know that it magically appears somewhere. So this is like I don't really touch Firehose. I just know how to put something to a stream.
Okay. Also, I'm unable to find that comment, but a community member has asked how can people connect with you. So I believe it's through your Slack and Discord channels. I mean, you can answer that question.
Yeah, we don't have Discord. We have Slack. So Slack,
yeah.
you just go DataTalks.club, and there is a form that asks for your email. Put your email there, click on the button, and you will receive an invite link. Unfortunately, now Slack is giving us a lot of troubles. So now the invite links work only for 100 people. Previously, it used to be like for 2,000. So basically, invite links expire quickly. If you have any troubles, just reply to this email that you get and say, I want to get in, and then we will take care of that. That's the best way. But you can also find me on LinkedIn and Twitter. I shared the information at the beginning. Or you can just Google my name and you will find me there.
Yeah, most certainly. And also, we have tagged Alexey on most of the posts that we've made for this particular session on LinkedIn. So you can go ahead and check there as well. On Twitter, you can just search for DataTalksClub, I believe. So you can find them conveniently.
Yeah, so there is an account for DataTalksClub and there is my personal account. So whatever works for you. I don't check the DMs for DataTalksClub that often. So if you want to connect with me, better to use my personal one.
Okay. This question that Ruaz asked is the deployment of a trained model in RPA or NVIDIA far different from web-based deployment?
I have never deployed anything in RPI or NVIDIA. I think it's pretty similar, except that perhaps you will need to use specially compiled binaries that are targeted for that specific architecture that you use for your target device. Other than that, I assume you can use the standard scikit-learn, TensorFlow, PyTorch, and so on. You just need to be careful when you prepare your Docker image to make sure that you have the correct binaries. That's my understanding. And again, I have never deployed to these platforms.
Okay. We are already past our time. We have a couple of questions. Can we pick them up or shall we answer them? Yeah. Okay.
Yes.
Awesome. So these are not exactly related to the topic, but yeah, people would love to know that from you. What are the skills you need for a data engineering role?
Funny you should ask. There is a bootcamp about that. It is running right now. So check the outline, uh, and these are the skills that we think people who put together this course, we think that are the skills that are needed for a data engineering role. So it's mostly data wrangling, putting together like a bunch of scripts into a pipeline, data pipeline, and then transforming the data. That's pretty much it. So check the outline, and that will contain the answer.
Okay. There is one question that we got in the beginning. Yeah, so Chris has asked, I have been training to become a data scientist. Did you start with a data engineering or did you start with data scientist role?
Yeah, neither. So I started as a Java developer. So first, my background was actually in databases. So kinda, you can call me a data engineer. I wouldn't call myself a data engineer, but when I look back at what I was doing, so I was actually like the Java programs when I was working at a bank. So the Java program we used was pulling an XML file from a message queue, transforming this, doing some enrichment, and then putting them to another message queue, and eventually that ended up in some relict database from 90s, something from IBM, which would qualify as data engineering these days, I think. But yeah, I don't think it matters, to be honest. Like, just there are many roads to data science. You can come from the engineering background, you can come from scientific background, like from research background, you can come from, I don't know, just from university. So all roads are fine, and just reinforce your strengths.
Okay, thank you for answering that. And the last question that we've got a lot of gracias, thank you messages on the comments. I'll also show them. But yeah, this is the last question that it's a short one. But yeah, if you could answer it, it'll be perfect.
Yeah, you can use Google Cloud Platform. That's one thing. They have a very similar thing, PubSub, I think, instead of Kinesis. I'm not sure. Another thing you can use is Confluent Cloud. Confluent Cloud is a managed Kafka. So Kinesis is similar to Kafka. Kafka is also like a message broker. And Confluent Cloud is a managed version of Kinesis. So you can use Kinesis, for example. I'm not sure how easy it is to use serverless things there, like Lambda, for example, because Lambda hides a lot of actually things that happen underneath, like how exactly you read from the stream, how you remember which things you consumed, which you have not. So AWS in this sense is quite nice, and I think in Google Cloud Platform and in Azure you have similar services. And then Confluent Cloud is also a nice thing to look at.
Okay. Thank you for answering that. I think that was a pretty elaborate one. So yeah, I think we are towards the end of a session. There are a lot of
Thanks for
thank you
having me.
messages that we have received. Yeah, so thank you so much, Alexei, for being with us today. I'll also share I'll add the links on the comments, so just stay tuned for a couple of minutes. But yeah, I'll probably I'll just thank you first because you've been very kind enough to answer all the questions. And there are a few people who have come forward to talk about the course that Alexei has prepared. So do go forward and check it. The data engineering bootcamp is also live, and the MLOps Zoom camp. It's really awesome. I will share the link with you so you can visit it and join it if you're looking to learn further on this. So thank you so much, and looking forward to hosting you again in DeFi in future.
Yeah, me too. Please invite me again.
Yeah, sure. Thank you. Bye. Yeah, so I'll probably I think I'll give a quick I'll add the links here towards on the chat section towards the end of the session. We'll probably close it. There's one thing that I want to announce since you all are here. So we have another live session this weekend on recommended systems. So if you would want to attend it, just go to defi.tech, visit live sessions, and you can find it out there. This is the exact same place where you would have found the session with Alexei. So thank you all for joining in. It was lovely having you today. Take care. Bye.